Assalamu alaikum.
Walaikum salam.
Okay.
It is so hot here. Oh my gosh.
Really? I've been seeing like for the past few days the matches of the Cricket World Cup being constantly cancelled because of rain.
Right.
Like,
Oh yeah, true. Yeah, first it was like heavy storming rain, but
yes.
then because of the humidity, the moisture in the air, it
Mm-hmm.
just got really, really hot.
I
So
understand. Okay. All right.
hottest time of the year. Yeah. Cool.
I mean, then again, it's like a rainy season, right? So you'd see within 2 or 3 days it might rain again. So,
Yeah, and then it'll get much more hotter again, and then it'll get cold and then hot, and I hate it because I don't want to freeze and sweat at the same time.
what is
I'd
the
rather not.
temperature like in like winter season?
Winter season's like a good high 20s.
That's bearable actually. It's not that
Yeah.
much more. Right? Like even
Uh,
if it was like 5 or 6 degrees centigrade, it was like very cold.
oh yeah, true. But this year it was pretty abnormal because it would get to what 6 degrees, 5 degrees.
Okay, that's
Um,
cool. Yeah.
and now it's getting to the high 30s, which is amazing.
Mm, okay.
All right, anyways,
Okay. Yes.
back to math.
Yeah. All right. So we were discussing about volumes, and what we understood was, in any case, if we are able to identify the height of a particular object, and we are identifying the surface area, then we will be getting the volume by multiplying these two. Okay, and we studied about the right solids and oblique solids, and how the volume is related to liquid capacity of a particular object. And then we studied about prisms, and what are the prisms. If the two sides of a particular object have the same surface, and all the points of these two surfaces are connected with straight lines, we will call that a prism. Okay, and this surface could be, in this case, like hexagonal, it could be octagonal, it could be not trigonal, triangular, anything. Okay. All right. So now, see a cube. For the cube, what do you understand by the cube? The cube is that particular three-dimensional object of which every side is equal. Okay, each and every side, it will have a total of, say, see, here are four sides, right? And like in this way, we have six sides. I mean, not six sides, actually six surfaces. Okay, and all of these six surfaces have four equal sides. Okay, so now the surface area of one of the surfaces will be L squared, because they are considering one side's length to be L. So that would be L squared, and then multiply it with the height, which is L. So you will get the volume to be L cubed. Okay. All right. And in case of a rectangular prism, the volume is area multiplied by height. So you could consider the area to be, say, for instance, which portion? So consider the area of this portion. What will be the area of this portion? Tell me. L multiplied by H, right?
Yes.
Yes. And if you consider that to be the area, then the height will be this portion, which is W. Okay. So the volume becomes L multiplied by W multiplied by H. Okay. In case of a triangular prism, what do we get? If this is the height, okay, which is L, and this is our surface, which is like a triangle, then it would be half multiplied by the base of the triangle, multiplied by the height of the triangle, and multiplied by the height of the prism, which is L.
Hmm.
Right. Now, let's get to our cylinders. Okay, now, as I said the previous day, cylinders are those objects which have like a sort of rectangular, not actually properly rectangular, but kind of rectangular, forward and backward side. Okay, why am I saying that it is not particular rectangular? Because whenever you say a cylinder, it's like sort of carved, right? It's like this sort of carved. Okay,
Yes.
the surface are this sort of carved. Okay. Well, let us just consider it, I mean rectangular for understanding, because if you want to like without considering the sorry, without considering it as a rectangular surface at the forward and backward side, if you want to, I mean, prove the area or the volume, you would need to involve differentiation, integration, sort of things like that. Okay, so let us just consider it to be a rectangular surface at the forward and the backward side. Okay, now
Okay.
again, as I said previously, what will be the surface area? See, these are the two surfaces, right? Okay, consider
Yes.
any of them. Okay, so this is r, and obviously the surface area would be pi r squared, right? Is it correct?
Yes.
Now see, in case of prism, what were we doing? We were considering that, okay, these two sides are like equal, then we are joining them. So that means we will take the distance between them multiplied by the area of one of these surfaces, we will get the volume. Now in this case, the thing also is the same. See, these two surfaces are similar, right? Which are like circles, right?
Yes.
And what is the distance between them? Height,
Height.
right? So then the volume would become pi r squared h, pi r squared h. Okay, and I mean, I am just saying for the understanding. Say even they have said like a prism. It's not a prism. It's like a prism. Okay. All right, because in
I think
case
it's
of
like a
prism,
prism.
I mean, they were just like joined with straight points. Okay. But in case of a circle, there have to be like thousands or infinite points at different points. They have to be joined. Okay. To get a cylinder. Okay. Understanding my point? You have to visualize
Yes.
it like a three-dimensional object. Okay. It's a little difficult. But see, you have to take infinite points and then join them to get the cylinder. Okay. Let's see what they have said. A cylinder is a solid object with ends that are identical circles and a cross section that is the same thing along its length, like a prism. Okay. Cross section means if you cut it into like what can I say, half or something, and see in detail. Okay, how would it look like? That is the cross section. Okay. As a result, it has a curved surface along itself. Okay, I've said already. As for prisms, the volume of cylinder is calculated by taking the product of the base area and the height. All right, now let's see what maths are given. Calculate the volume of a cylinder of radius 10 centimeters and height 15 centimeters and correct to 10 decimal, sorry, 2 decimal places. Hence, calculate its capacity in liter to 2 decimal places. Okay, so first of all, you have to calculate the um, volume, which is pi multiplied by 10 squared multiplied by 15. So you will get something, some value, and the value would be in centimeters cube. Okay, centimeters cube. And
Hmm.
I previously told you that 1 centimeter cube is equivalent to 1 milliliter. Okay, and also if it's water at 4 degrees centigrade, it would be equivalent to 1 gram. 1 gram, 4 degrees centigrade water. Okay.
Huh.
So based on that, you can, I mean, just transform it, okay, into milliliters. Okay. And then by dividing with 1,000, you can get liters. So see, you are getting the value to be 4,712 centimeter cubes. That means 4,712 milliliters, and just divided by 1,000 to get the value in liter. Okay. All right. Okay, one thing, you told me that within 2 weeks, you will give me the physics and chemistry book. So, what is the
Oh
procedure?
yeah, true. They're still under doing something. I asked the teachers and they said that it's not in their hands anymore. It's someone else doing them, and I don't know who they are, so I
Okay,
can't really
in
contact
that
them.
case, can you at least send me the index of the two books? I think you've got hard
Sure.
copies, right? Okay, just the index
Yes.
so I can understand what you are going to read. Okay, all right.
Yes.
All right, now cones. If you are a fan of like ice creams, you would probably be familiar with this shape. Or like in case of birthday parties, we use them as hats. Okay, these are the cones. Okay.
Yes.
So how can you get a cone? So let me give you that understanding first. Say you've got a right angle triangle. This is a right angle triangle. Okay. Consider this to be an axis. Axis, a rotational axis. Okay. Now what you are going to do is you could do it either clockwise or anti-clockwise. You will just like rotate it like this. Okay. Now the
Mm.
end result would be something like this. It would look like, see, when you are rotating it, say this is the rotational axis. So I'm denoting it with like this way, and the hypotenuse will be like in this way. Okay. This is how it will look like. Okay. After the rotation is completed, you have to complete a full rotation. So this is the starting point, and after the full rotation is completed, you are getting back to this point. So in the surface, it will form this sort of a surface area, which is obviously again pi r square, and you are getting the hypotenuse like in the left side connecting to this point, and exactly at the opposite point you are connecting the hypotenuse as well. Okay, so actually there's some a little bit wrong. It will be something like this. Okay, all right. So now as you can understand, our height is this portion, right? There is no confusion in that. This is our height,
Yes.
and the surface area will be again pi r squared. Okay. Okay. Now this is a right angle triangle. Okay, let's see what they have said. A cone is a solid object that is similar to a cylinder in that it has one end that is circular but different in that at the other end that is a single vertex. Okay. So see, one end is like circular, but the other end is not circular, as it is of cylinder. The other end is like just as one single point. Okay. Okay, one thing I forgot to tell you in case of cylinders, what you do in case of cylinders is, see, you have got a rectangle. Okay. Now you will rotate it, keeping this as the axis. So this is our axis. All right. Now you will rotate it like this. If you rotate it like this, what will be the end result? The end result would be something like you are getting something in this space, and this one is coming here at this point and at this point as well. Okay. All right. And you are getting the cylinder. Now notice that you would sort of think like, okay, this sort of like is looking, it's getting linear or something like that. The answer is no, because if you see the center point of this radius and the center point of this radius, okay, they're exactly at this point. Okay. I mean, I will not be able to draw an exact circle because obviously this is a three-dimensional object. But if you see a cylinder by yourself, you will see that the distance between this point and the distance between this point and this point is the same. Okay. Why? Because obviously this denotes the diameter of the circle. So obviously they will be at the same point. Understand my point?
Yes.
Okay. All right. So just like if you get any question, that is why I let you know how cylinders are formed. Okay, fine.
Mm.
So now where was I? So it can be shown that if you have a cone and a cylinder with identical circular bases and heights, the volume of the cylinder will be 3 times the volume of the cone. The proof of this is beyond the scope of this course. As I said, you will need the use of differentiation. Okay. And you might be like, I mean, given some idea about differential calculus, like in the end of 11th class or 11th standard. But I don't know. I don't think the proof of this will be given to you, but you will be, I mean, given maths with like practical things of this. Say for instance, how can you build a cylinder with the least cost? Okay, you can I mean get those ideas from differential calculus. Okay, so you will see those maths, and those are like very interesting maths. I particularly enjoyed them a lot. Okay, like say there will be maths like say Coca-Cola company is willing to save some money by designing the best possible cylindrical shape ever. Okay, so how would you define the dimensions of that particular cylinder? So these sort of things
Mhm.
would get the no, it's very easy. When you will understand, they will become very easy. All right. So the volume of a cone can therefore be calculated by using the formula for a comparable cylinder and divided by 3. 1 by 3 pi r squared h. As you can see, pi r squared, then the height, and then 1 upon 3 multiplied. Okay. All right. Let's see. Calculate the volume of a cone of radius 20 centimeters and a height of 36 centimeter. Correct one. Okay. So just like plugging in values. Okay. Right. Pyramids. Okay, so pyramids, if you
Pyramids.
were interested in Egyptian civilization, you would have a
Mm.
great idea about pyramids. And why did they use
Mm.
them? It's particularly it was for mummification, because they felt like if a person dies, his or her soul should be like in a very what can I say, very good state, or in a very gratified place or something. Okay, and there was
Sort
also,
of, yeah.
you would know, I don't know if you know, I've learned it from the courses of mine. See, there was particular chamber for the storage of these. Okay, and there was a chamber like somewhat like open, or they would open for a certain time. Why? Because the soul might go inside and outside. Okay, see
That's
how
pretty
they
cool.
were, their beliefs were.
Just visiting.
Yes. So they thought it like that. But one thing is certain, that at that stage, like building these monuments, it's like beyond imagination. And if we like want to think like scientifically, it's not possible actually to get the understanding of that. Okay. All right. So those are like religious topics and like things that would be like say hours and hours of discussion. I'm not going there. Okay. Pyramid is a solid object whose base is a polygon and whose sides are triangles that meet at a single point. Okay. The most famous examples are the pyramids of ancient Egypt, which were built as tombs for the pharaohs. Okay. A pyramid is named after the shape of its base. Okay, so it could be like square pyramid, it could be triangular pyramid, it could be hexagonal pyramid. Okay, and so on, so on. For
Mm.
example, a hexagonal pyramid has a hexagon as its base, polygon. Okay, so the most common are like square pyramids, triangular pyramids, and so on. So, okay, all right. Now, again, for calculating the volume of pyramid, what you are going to do is calculate the surface area and multiply it with height. In case of all the solids, we have seen that. Okay, so it will
Mm.
change based on whatever surface area we are taking. Say in case of square pyramids, it will be the square surface area times the height. Okay. Now, why is 1 upon 3 taken? I cannot explain to you that. Just remember that 1 upon 3 is also like used. Say the one explanation could be like in case of say cones. As you can see, cones meet at one vertex point. Okay, all right. So in that case, we were like dividing by 3, and in case of pyramids, you see, we are also getting one vertex point. Okay, so that is the explanation behind that. But how is this like formula gotten? That is not, within the scope. Okay.
Okay.
All right. Now
I've got a
triangle.
question.
Yes. Go ahead.
So say for example, you get a square-based pyramid
Mm-hmm.
and put it on its side. So there would be just a triangle on its side, like on the
Yes.
bottom,
Mm-hmm.
while the square on the other side, yeah. Would that affect the answer if you calculated the base of the triangle as it's
Okay.
now the base of the
So what you mean is like, say this is a surface area, but you are going to
yes.
shift it like, say this is the triangle, and based on that, the rotation will change, right? Then that is what you are saying.
Yes.
Okay.
Yes.
So now see, if you view it like that, does it satisfy the definition of a pyramid? Okay. Because whenever we are saying that we are getting a pyramid, it has to like the upper point, it has to be at one single vertex point. Okay. Now,
Mm.
whenever you are considering like it's staying on the I say triangular surface, okay, what should happen in that case? In that case, we will get some like lines from three of the vertexes of the base, which is the triangle. Okay, so there should be three lines. Okay, three lines like that. So that should be the shape of the triangle. Sorry, the other sides to get a pyramid. But in case if you like shift the base like this, are you getting three lines are there? And the answer is no. You are not getting three lines. You
No.
are actually getting four lines from the three vertices of the base. Okay. So that does not satisfy our like definition of pyramids. Okay. In case of any like drawing pyramids or like constructing pyramids, there has to be the same amount of lines as they are in the as they are vertex points in the base. Okay. So if you are considering
Okay,
any triangular, yes, go ahead.
I need to do something real quick. Sorry about this, but
Okay, okay, all right.
could you please
Have
give
you
me a
got the
minute?
answer?
Yes, I
Okay, all
think.
right.
Hopefully. I can get the answer. Yeah. Okay. I'm back. Okay. Sorry, my brother just came back and he just got his car lowered, so
Okay, no
ah,
worries. Another thing I have to mention in case of pyramids is that how can you get the like height? Okay, from what point are you calculating the height? Okay, that is a very important point. Okay,
from
see,
the
in
base
case
to the
of
apex.
square pyramids, you are like if you connect the diagonals, you will get this point and then connect it with the vertex. Okay, that will be considered as the height. But what in the case of like triangles, in case of hexagons, octagons, and so on, so on. Okay, so there is one particular point for any geometric shape or geometric object on which all the gravity lies. Okay, we call it the center of gravity, right? The center of gravity or center of mass, you could say as well, center of mass or center of gravity.
Yes.
Now there are different sort of I mean ways to find that center of mass or gravity. I won't discuss it now. I don't know if it's in your syllabus. If it's in the syllabus, I will discuss it. So now you have to figure out the center of mass or gravity of that particular base and then connect it with the vertex point to get the height. Now think again, if you change the base to triangle from square shape, okay, the center of mass or gravity will obviously change. You can understand that much, right? The center of mass or gravity will change, right? Yeah, okay. So now if that point changes and you connect the vertex, okay, so obviously it's bound to change the height of that particular pyramid, if it stays pyramid. Say for instance, we are considering it stays pyramid. Okay. All right. So then the height will change, which is the h. It will change. Okay. Right. Is it correct?
Yes.
Now again, think about it. Where the base area would become half times the base of the triangle times the height of the triangle. That will also change, right?
Mm.
So after, I mean, considering all of this, what we can understand is that yes, if you like rotate the base or change the base of a pyramid, and if it stays the pyramid, let's consider if it doesn't even stay pyramid, what I can say clearly is that the volume will change. I mean, not the volume will change actually, like the volume's formula or something, it will change. Okay, all right, understand my point?
Yes.
Okay, and let me ask you a question. What do you think? If we just rotate it, should the volume change? We have got the
No.
idea of volume up until now. Should the volume change?
No.
Volume won't change. Okay. Like just by rotating something, you don't change the volume and neither do you change the capacity. Okay.
No, you
Right?
do not.
But the calculations would become very difficult. Okay. As I said, like the center of mass or gravity will change. Okay. Then base area
Yeah.
would be calculation. It will be difficult. So on
Yeah.
so. All right. All right, now calculate the volume of pyramid that is 75 centimeter tall, which is the height, and has a rectangular base. Say in every case, whenever you will be given a map, they will look, I mean, say what is the base of that particular pyramid, because this is very important. Okay, for constructing a pyramid. Even if you see, like say in practical world, think about what Egyptians did. Just consider this shape to be just like rotated. Okay, consider it like that. The whole structure would, if even if it doesn't collapse, it will be like very, what can I say, chaotic, right? The inside portion, it will be like organizing, it will become very chaotic. I mean, why am I saying these things? Because whenever we are dealing with three-dimensional objects, very, I mean, important to visualize by itself. Okay, that is why it becomes really difficult. Like whenever we are studying two-dimensional objects, it's really easy, like drawing it on paper plane and all, it gets really easy. But whenever you are considering three-dimensional objects, you have to visualize it properly. Okay, understand my point? All right.
Yes.
I haven't seen like very difficult maths up until now. Maybe those were would be in exercises. You will see why is it important to visualize that. Okay, now calculate the volume of a pyramid that is, okay, so 75 centimeter tall and has a rectangular base. So rectangular base's area will be 45 times 38. Okay, then divided with 3 and then multiply with 75. Then you will get the volume of pyramid. All right, understand?
Yes.
Okay, now for spheres. Okay, so how do we get the spheres? Let me demonstrate that first. So say for instance, if you have a semicircle. Okay, you have a semicircle. So we will consider this to be the axis. Okay, so now just rotate it with this axis, then you will get a sphere. Okay, you will get a sphere. All right. So yes, it's particularly easier to understand because we were starting with a curved surface from the very beginning, not like in case of I mean cylinders or like cones, where we were starting with right angle triangles or maybe rectangles. So it's particularly easier to understand in that way. Okay. Now let's see what they have said. A sphere is a solid object that has a curved surface such that every point on the surface is the same distance from a central point. Yes, it's a very important to understand. See, I mean, if you would see, do you have a like ball, like a sponge ball or maybe a tennis ball at your
Yes.
feet?
Yes, I do.
Okay, so consider that ball. Okay, now again consider that particular point where the all of the mass or the gravity of that particular object lies. That would be the center point, center of mass, or the center of this particular object. Okay. Now, as in case of circles, what did we consider? That from for the case of circles, from the center, the distance of the circumference from at every point would be similar. Okay, and the distance we considered was the radius. Okay, now spheres are also circular objects, obviously in a three-dimensional plane, but it's a circular object. Okay, so that is why the center, like which lies in the like very inside of that particular object, which we cannot see. Okay, so from that point, if you connect every point of the surface, you will get the same distance, and the same distance is termed as the radius, or r. Okay, this is also the radius. Okay, it's a little difficult.
No, it's
Okay,
never difficult. Mostly.
right. So the formula for calculating the volume of a sphere has been attributed to the ancient Greek mathematician Archimedes. Okay, all right, which is 4 by 3 pi r cube. Now there is a particular easy understanding. I can give you the video link to that, but that is in Bengali. Okay. Actually, I would look through that video and then make you understand about the topic. But I cannot obviously show you the like graphical demonstrations about that. So I would suggest you see that video, and obviously whatever you don't understand, you will not understand the Bengali that much. And then we can discuss it about that. But for the time being, what I can say is, see, what is the like considering the surface of this sphere is difficult, right? What we were doing in case of, say, for example, we're calculating the surface area and then the height and so on, so on, we were doing that, right? So it becomes really easy. Okay. Now what happens in this case is that if I'm not mistaken, so it was something like what it was like 2 pi r, and then somewhat like r squared or something. Okay, and then obviously you understand that 1 upon 3 is like, in case of, say, we did for cylinders, in case of like what was it, right angle and something like that, it was some sort of like this. I don't remember that particular operation because I saw that after I had completed all of my degrees at like standard 10 and standard 12. So I was just seeing it for hobby, not for uh, like for teaching someone or like reading it or something like that. So I will see this formula or the what can I say, the proof of this formula, and let you understand the next day to as much extent possible to you. Okay, all right. But for the timing, just remember this formula that the volume is 4 upon 3 pi r cubed. Okay, all right. And how spheres are formed, that is easy, right? So there will be a rotational
Yes.
axis of a semicircle, and based on that, you will rotate.
Cool.
Okay, and another thing, that is the surface area would be, surface area for spheres are 4 pi r squared. Okay, 4 pi r squared. Okay, all right. Now I remember, yes. So it was 4 pi r squared, then multiply it with r, okay, the radius, and divide by 3. It is, that is how it was gotten. Okay, the like volume, okay, to the simplest of ways. The 4 pi r square, it is the surface area. It is the surface area. Okay, and in this case, we are considering the radius, not like the height. Okay, all right, because you could say that radius is the height. You could say it like that. Okay, because it's the measurement from the center to the say highest point of the surface. Okay, so that will also be r, right? So in that way, you could consider that to be the
Yes.
height. Okay, and the surface area is 4 pi r
Mm.
squared. Okay, so in that way, you could like consider it. Okay, so okay, calculate the volume of a sphere of radius 63 centimeter. Correct to one decimal place. So just like plugging in the values, I'm not getting into that. Okay, so let's see the volume of some composite solids. Now comes the creativity. Okay, before that, let me give you another link.